I have compiled some communication questions from recent test papers. They should help you to understand communication problems and write good answers. Now, the idea here is that once you read the problem, you should try to answer them yourselves, stop the video, and once you're done, then watch the video and see how I can give you some inputs, okay, to help you communicate better for these questions. C is for communication. Question number 1 on communication, C1, has got 5 marks. And the question is, complete the following table. Here we have a function x times x plus 4 square times x minus 4 square. So that's the given polynomial, and you have to write polynomial name and behavior, number of turning points, number of zeros, and symmetry. So this information is required about the given polynomial, okay? So answer your questions, and then once you're done, watch the video to see how you can see your answers and how you can communicate better. Okay. Name of the polynomial. Name of the polynomial comes from its degree, right? So let's count the exponents. 2, 2, 4 and 1. 5. Therefore the degree is 5, right? So it's a degree 5 polynomial which we call quintic. End behavior. To find the end behavior, you can see the degree is 5, which is odd degree. So we have an odd degree, right? What else? Leading coefficient. So let's say an is leading coefficient positive or negative. This x is positive, this is positive, this is positive. So when you multiply them all, you get positive. So it is greater than 0, right? It is positive. Now, if it is odd degree and positive, then what do you expect about the end behavior? Positive means right side up, correct? Positive means right side up. And odd degree means opposite ends. So that's the end behavior, right? So we can write this end behavior as when x approaches minus infinity, y approaches, you can see that, minus infinity, right? And when x approaches plus infinity, y approaches plus infinity. So that's your end behavior. Number of turning points. We can find the number of turning points from the number of zeros. Do you know how? The formula is number of zeros minus 1 plus number of even zeros. Why? Let us say there are 2 zeros. Let me explain you this concept. And let's say graph is going from here, right? So if there are 2 zeros, if you cross the line, you have to come back, right? So between any 2 zeros, there will be 1 turning point. So zeros minus 1, correct? That's how you get the first part. And how about even zeros additional? Now let's assume we have 3 zeros. If you just cross the line, you got 2 turning points. One here and the other here, correct? But let us say this is even zero. Then it forces you to turn. So if you cross here and if it is even, it forces you to turn. So we have one additional turn. Do you understand that additional turn? That is even zero. And those additional turns are only because of even zeros, therefore we add them. Right? So here we can see zeros are 1, 2, 3. We have to answer here number of zeros. Let's say number of zeros are 3, right? So we have 3 zeros, right? Minus 1, that means zeros minus 1, plus even zeros How many even zeros we have? 1 and 1, 2, correct? 2 even zeros. And therefore, these are number of turning points. So we have 3 minus 1 is 2, 2 plus 2 is 4, correct? So can you sketch this graph? This is definitely not this graph, right? It's a degree 5, and I have only shown degree 4, right? Yes. So here we have a single zero x, right? And two zeros at plus and minus 4, correct? So x we can take now. So let's forget about this, right? So this is general, right? Let me cross this out so that there's no confusion, right? Let me sketch this here for you. So let's assume this is the 0 at x, and then we have a 0 at 4 and minus 4 plus 4. Let's say this is at minus 4 and this is at plus 4, correct? End behavior is from here to here, correct? Now since this is even, when we go through this 0, we'll cross it, and here we'll go straight, right? And here we'll again cross. So our graph is like this. Do you see that? And this function will be symmetric about y-axis, and therefore it is also even. You see? From here you can count the number of turning points. 1, 2, 3, 4. So that makes it all. So this is for our function x times x plus 4 whole square times x minus 4 whole square, right? This is at 0 and this is at minus 4 and this is at plus 4, correct? That's our graph. Even function you can prove. How? F of minus x. So if you do f of minus x, what do you get? You get minus of x, right? For this function. Sorry, it's not even, so odd. You get minus of x, and then you write minus here. You say minus x plus 4 whole square times minus x minus 4 whole square, correct? Now, when you do square of this, you can think like this. Take minus common. When you take minus common, you get x minus 4 here, right? And the square of minus will be plus, and you get x minus 4 here. Is it okay? Once you take minus common here, you get x plus 4 there, correct? X plus 4, and the minus becomes positive, so you get x plus 4 here. You will see, oh, of course, square, right? And you will see this is minus of our function. So it's minus of f of x. Let us say this is f of x. Do you understand? So it is odd symmetry. I'm sorry, that was wrong. It is symmetric about origin. Do you see it's symmetric about origin? So this point and this point, they are all symmetric about origin. And it is a odd symmetry, okay? Degree 5, odd degree, and this is odd symmetry. What helped us for this being odd symmetry? Because we have these two symmetric zeros because of that, okay? I hope you understand. Okay, thanks.